Hello everyone, welcome to my channel GVS Care. In this module, let us discuss thermochemical reactions and the second law. Please subscribe to my channel, like, share and comment on my videos. Now let us discuss about exothermic and endothermic reactions. Now let us see exothermic reaction. Exothermic reactions are those which proceed with the evolution of heat energy. So now let us take an example. A plus B gives C plus D plus Q. Q means here heat energy. So heat energy releases here. Now reaction. So if the reaction is carried out at constant temperature and constant volume, the heat evolved is equal to the change in internal energy. So in case of exothermic reactions, heat energy is evolved. That is, the energy of products is less than that of energy of reactants. Therefore, energy of products is less than energy of reactants. So change in energy, that is internal energy, delta U equal to UP sigma UP, that means the sum of the internal energies of all the products minus sum of the internal energies of all the reactants. Therefore, since internal energy of products is less than that of reactants, therefore it is less than 0 or negative. If the reaction is carried out at constant temperature and constant pressure, then the heat evolved is equal to the change in enthalpy. Now let us write this. Delta H is equal to sigma HP minus sigma HR. That is, change in enthalpy or amount of heat evolved is equal to the sum of the enthalpies of products minus sum of the enthalpies of reactants. In exothermic reaction, enthalpy of products is less than enthalpy of reactants. Therefore, delta H is equal to sigma HP minus sigma HR is less than 0 or negative. So, negative sign indicates the release of energy. So, exothermic reaction we can understand with the help of a graph. Here this is reaction coordinate and this is the energy or enthalpy coordinate. Here this is the total enthalpy of products, that is HP. This is the total enthalpy of reactants, that is HR. So here enthalpy of reactants is more than that of enthalpy of products. Therefore delta RH means heat of reaction or energy change in the reaction. Delta RH equal to sigma HP minus sigma HR. That is sum of the enthalpies of all the products minus sum of the enthalpies of all the reactants. Since HP is less than HR, that is enthalpy of products is less than that of reactants, therefore HP minus HR is less than 0 or negative. So negative sign indicates energy releases. So negative sign indicates the release of energy. Now let us learn about the endothermic reaction. A chemical reaction which proceeds with the absorption of heat is called endothermic reaction. So when a reaction goes on, heat is taken. For example, A plus B plus heat energy is supplied gives C plus D. So this we can write it as A plus B gives C plus D minus heat. Heat can be represented by Q. Therefore, A plus B gives C plus D minus Q. So, as heat is absorbed, it is the heat absorbed is shown with plus sign. Heat absorbed or internal energy change or enthalpy change. Therefore, A plus B gives C plus D. So delta U is equal to positive or This is when the reaction is carried out at constant temperature and constant volume. Or A plus B gives C plus D, therefore delta H is equal to positive. Here the reaction is carried out at constant temperature and constant pressure. Now we can try to understand the endothermic reaction in terms of a graph. So here this is the total enthalpy of reactants and this is the total enthalpy of products. Enthalpy of reactants is less than that of products. Therefore, delta H is equal to sigma HP minus sigma H. So, the delta H is found by the formula sigma HP minus sigma HR irrespective whether it is exothermic or endothermic reaction. Here, enthalpy of reactants is less than enthalpy of products. Therefore, we are subtracting smaller value from greater value. Therefore, delta H is equal to sigma HP minus sigma HR, which is nothing but greater than 0 or positive. Therefore, the net heat, this is the net heat absorbed from the surroundings. So, this is the net heat absorbed from the surroundings. Now, thermochemical equations. A thermochemical equation is defined as the chemical equation which indicates the amount of heat evolved or absorbed during the chemical reaction in addition to the quantities of the reactants and products. So, let us write an example for this thermochemical equation. The reaction is 2SO2 plus O2 gives SO3 plus this is 2SO3. 694 kilojoules of energy. 694 kilojoules of energy. Therefore, here plus indicates heat is evolved. Heat evolved means it is exothermic reaction. For exothermic reaction, delta H is negative. Therefore, 2SO2 plus O2 gives 2SO3. Therefore, delta H is equal to minus 694 kilojoule. So, this is the thermochemical equation. And this thermochemical equation, apart from the indicating, apart from the mentioning the energy changes, we have to mention even the physical state of the reactants also. Physical state of the reactants must be mentioned. That is SO2 is gas plus O2 is also gas gives SO3. This is also gas. Delta H is equal to minus 694 kilojoule. Now let us discuss some important conventions about the thermochemical equation. The coefficients of various substances of a chemical equation represent the number of their respective moles. In a thermodynamic interpretation of an equation, coefficients are not interpreted as a number of molecules. Hence, it is acceptable to write the coefficients in fractions wherever it is necessary. That is, so H2 plus 1 by 2 O2 gives H2O. Here, one molecule of hydrogen combines with a half molecule of oxygen and we get one molecule of water. Next point, the value of delta H in a thermodynamic equation corresponds to the enthalpy change taking place when a specified number of moles of various reactants and products are involved in the reaction. Third point, in case of coefficients in the chemical equation are multiplied or divided by some integer, the delta H value also must be multiplied or divided by the same number. For example, hydrogen plus half molecule of oxygen we get water and delta H is minus 286 kilojoule. Suppose if we multiply this equation with 2, if the whole equation is multiplied by 2, the delta H for the new thermochemical equation is given as, so here it is multiplied, this becomes 2H2 plus O2 gives 2H2O. That means here when we multiply half with 2 we get 1. This is 2H2O. Therefore, delta H also must be multiplied. Here minus 286 is multiplied by 2. Therefore, we get minus 572 kilojoule. When a chemical equation is reversed, the magnitude of the delta H remains the same. However, its sign is reversed. For example, If delta H is positive for a forward reaction, it would be negative for a reverse reaction. That is, H2 plus half O2 gives H2O and delta H is minus 286 kilojoule. If you reverse this reaction, that means if you take water as reactant and hydrogen and oxygen are products, then so H2O liquid gives H2 and O2, half O2, then delta H becomes plus. As it is minus here, as reaction is reversed, therefore sign also reversed. Therefore here the delta H is plus 286 kilojoule. Now let us discuss explanation of spontaneity of chemical reactions based on second law. How second law explains the spontaneity of different process. Now there are two types of reactions with respect to the heat changes, that is exothermic reactions and endothermic reactions. Now let us discuss in these two cases. So in the first one, exothermic, first of all, what is second law? Second law states that entropy of the universe increases in the course of every spontaneous process. So whenever there is a spontaneous process, the entropy increases. That means for any spontaneous process, entropy of the universe changes. What is the entropy of universe? Entropy of universe, delta S universe is equal to delta S system plus delta S surroundings. Delta S surroundings. That means out of these two, entropy of system or entropy of surroundings, both put together, this is nothing but entropy of universe. Therefore, entropy of universe should be more for a spontaneous process to occur. Now let us see exothermic reactions. Exothermic reactions. In exothermic reactions, what happens? Heat is evolved. Heat is released. Heat is released. That means the heat taken by this heat released by the system. Heat released by the system. So the released heat is taken by surroundings. Surroundings. As surroundings take this heat, what happens? Delta S surroundings increases. Delta S surroundings increases. Right. Now, if delta S surroundings means it is plus. If delta S system is also greater than 0, then delta S universe is equal to delta S system plus delta S surroundings. So here, during the endothermic reactions, heat is released. The released heat, the heat released by the system is taken by surroundings. Because the heat is taken by surroundings, the randomness increases. As randomness increases, delta S surroundings increases, that is positive. If delta S system is also positive, that is greater than 0, then the delta S universe is nothing but delta S system plus delta S surroundings. Therefore, this is greater than 0. Therefore, the process is spontaneous. Process is spontaneous. So this way, try to understand by diagram. So this is the system. The system gives the heat because it is exothermic reaction. The heat is given to the surroundings. When heat is given to the surroundings, entropy increases. That is, the randomness increases. That is, delta S surroundings is greater than 0. If delta S system is also greater, then delta S universe is also referred as delta S total. So delta S total equal to delta S system plus delta S surroundings. So this is plus, this is plus. So here it is already shown delta S surroundings is greater than 0. That means it is plus. Delta S system is also plus greater than 0. Therefore, when two positive values are added, then we get a positive value. Positive value. Therefore, the process is spontaneous. Process is spontaneous. In case of exothermic reactions, let us take an example. Magnesium burns in air, we get magnesium oxide. And here, delta H naught is equal to minus 1202 kilojoule. So here this is solid. this is gas, whereas the product is solid. Therefore, here as the product is solid substance, that means the disorderedness decreases or randomness decreases. Therefore, delta S system is less than 0. Less than 0. So here in this reaction, delta S system is given as a minus 217 joule per Kelvin. Right. Now, delta H is equal to minus 1202 kilojoule. So this is given by system. As it is given by system, this is taken by surroundings. Taken by surroundings. As it is taken by surroundings, therefore this becomes plus 1202. The heat is given by the system, therefore represented by minus. As the heat is taken by surroundings, the energy of the surroundings increases, therefore it is plus. Now, delta S surroundings is equal to Q by T. What is T here? 1202 kilojoule by temperature is 298 K. This is a normal temperature. It is for any reaction we have to consider the NTP. NTP means normal temperature and pressure. Normal temperature is 25 degrees centigrade, which is nothing but 298. Therefore, if we calculate this, we get the value plus 4.03 kilojoule K minus 1. So this is nothing but 4.03 into 10 to the power 3 joule K minus 1. Because here the delta S for system is given in joule per K minus 1. Therefore, this is converted. Now, delta S total is equal to delta S system plus delta S surroundings. Delta S system how much? Minus 217 joule plus how much is this? This is 4.03 into 10 to the power 3. Ultimately, we get the final value is 3.81 joule K minus 1. Therefore, here the delta S total becomes positive. Delta S total becomes positive. As delta S total is positive, therefore this process is spontaneous. So magnesium burns in oxygen gives magnesium oxide. This becomes spontaneous. So what is the condition here? Out of delta S and delta S system and delta S universe, even if the delta S system is negative, if the delta S surround is greater than delta S system, then the process becomes spontaneous. So this we can understand by a diagram. Say here delta S system, heat is given here. Since heat is given here, the entropy or the randomness of the system decreases. So this heat is taken by surroundings. As heat is taken by surroundings, the randomness or disorderedness increases. Now here delta S total is equal to delta S system plus delta S universe. Now this is minus here. This is plus here is equal to is greater than 0. If delta S surroundings is greater than delta S system, then this process is spontaneous. Now let us discuss about endothermic reactions. Endothermic reactions. Endothermic reactions means heat is absorbed by the system. Therefore, system absorbs heat. System absorbs heat. As the system absorbs heat, delta S system becomes positive. Since system absorbs heat, consequently, what happens? Delta S surroundings, energy of surroundings decrease. Energy of surroundings decrease. If energy of surroundings decrease, delta S surroundings becomes less. Delta S total is equal to delta S system plus delta S surroundings. So here delta S system becomes positive, and since heat is lost by surroundings, this becomes negative. So delta S total is positive provided delta S system is much more greater than delta S surroundings. So positive provided delta S system is greater than delta S surroundings. So this we can understand by using a diagram. Here system takes heat from the surroundings. As system takes energy from surroundings, delta S system increases. Since surroundings lose energy, its entropy decreases. Therefore delta S total is equal to delta S system plus delta S surroundings. Therefore this is positive, and of course this is negative. So this is positive, equal to positive if delta S is positive value, if delta S system is greater than delta S surroundings. Now let us discuss the conditions for spontaneity in terms of entropy, what we discussed till now. Let us list out. So this is reaction type. Reaction type means either exothermic or endothermic, delta S system, delta S surroundings, and delta S total. Therefore here exothermic reaction, exothermic, delta S system is positive, delta S surround is also positive, then delta S total is positive. Therefore the reaction is spontaneous. That means both delta S and delta S surroundings are positive, then the process is spontaneous. Now the same exothermic reaction, this is first condition, second condition. Exothermic reaction, delta S is negative, delta S is positive, then this becomes positive if delta S surroundings is greater than delta S system. Delta S surroundings is greater than delta S system. Then endothermic reactions. For endothermic reactions, delta S becomes positive, delta S surroundings become negative. Delta S becomes positive if delta S system is greater than delta S surroundings. So these are the conditions for spontaneity in terms of entropy. Apart from what we discussed, let us extend this. So delta S total and nature of the reaction, nature of the process. Delta S is greater, therefore the process is spontaneous. If delta S equal to 0, then the process is in equilibrium. Delta S is negative, then the process is non-spontaneous. Non-spontaneous means the process does not carry out. So if delta S is negative, the process is non-spontaneous. So these are the conditions for spontaneity in terms of entropy.